Okay. Oh, that's facing the wrong way. All right. 4.4. Proving lines parallel. This is just the converse of the previous sections you've done, meaning it's just everything in the opposite order. Instead of saying that two lines are parallel, we're going to have two lines. We're not going to say that they're parallel. Then we're going to have a transversal. Okay? And then we're going to have different tests to figure out whether they are parallel. But it's basically the same thing. In other words, what do you think would happen if the alternate interior angles were congruent? If you have found a set of alternate interior angles to be congruent, what do you think you could say about the two lines? They're parallel. Because in the last section we had a theorem that said if these two lines are parallel, then the alternate interior angles have to be what? Congruent, right? So in this section, what we're going to do is we're going to start with giving you information like, hey, guess what? This angle is congruent to this one. And you're going to say, oh, by the converse, because their alternate interior angles are congruent, then I can say that this line has to be what? Parallel to what? That line. Okay? So right here, what we'll do is we'll make kind of a chart, and we'll say tests for proving two lines parallel. Our first test. If a set of alternate interior angles are congruent, then the two lines are what? Two lines are parallel. So our first test is if we can find a transversal and we find a set of alternate interior angles to be congruent, we can say what? The two lines have to be what? Parallel. Our second set, what do you think's next? If a set of alternate what? Exterior angles are what? Congruent, then what do you think you can say? Then the two lines are what? Parallel. What does that look like? Well, you've got the same situation here, but you'd have a set of what? Alternate what? Exterior angles. See that picture? What's next? If a set of, how about we say corresponding angles are congruent, then what do you think you can say? Then the two lines are what? Parallel. Well, how's something like that going to go? Look, what's corresponding mean? Like top left, right? Same place. That's all the ones that if they're congruent, proven to be parallel. The last one is if a set of consecutive interior angles are, and then this is a different word, supplementary. What does that mean? They add to 180. Then the two lines are what? Parallel. What would that look like in a picture? Be like this one and this one adding to what? Or this one and this one adding to 180. So do you see how it's the same thing we've been doing? It's just we're going in the opposite way. By saying this happens, we say the two lines are what? Parallel. By having corresponding angles that are congruent, you can say the two lines are parallel. So these are tests for proving lines to be parallel when they have a transversal drawn. They have another theorem, 4-8, but in my humble opinion, isn't it the same thing as saying corresponding or any of those? It's a combination of those other three. If you ask me, it's a little. Has everybody got this down? You guys still writing? Okay. And you'll see a lot of good things in this book. In this section, they have a concept summary. Show that a pair of corresponding angles are congruent. Show that a pair of alternate interior angles are congruent. Be able to show that alternate exterior angles are congruent. Be able to show a pair of consecutive interior angles as being supplementary. And then the last one says show that two lines are perpendicular to a third line. What it means is if that transversal is perpendicular to both lines, then they have to be parallel. If you look at this picture, look up here. Let me ask you a question. If this line T is perpendicular to both of these, it makes this 90 and this 90, right? What does that basically tell you? That this angle is what? Congruent to what? Isn't that just the corresponding angle theorem? So that's why, to me, this is a little overkill. Don't worry about this one. If you know the other four, you can get everything you need, okay? And if you know what perpendicular means. All right, let's do problems on that worksheet. Now, what you'll find, and this may confuse you because these first ones, or let's start with number 7, so we can kind of get with the same. What they want to do is name the pairs of parallel lines or segments. So what we're going to do is see if any of these tests yield two parallel lines. So what you have to do is you have to have a transversal always, and then the two lines you're trying to see if they're parallel. First of all, I could make L my transversal, which means I'm going to forget about everything else over here, okay? So we'll put this over it. We're going to forget about everything else. Now, are there any tests that would prove that this line N is parallel to P? This is my transversal. If this is 132 and this is 148, how do those two angles relate to each other? They add the 180. What type of angles are they? Consecutive interior. They're both on the inside and they're right on top of each other. They add to 180. Do I have a theorem that says if consecutive interior angles add to 180, then the lines have to be parallel? Do I have one of those? Yes. I do, don't I? So by these two, I could say that N has to be parallel to what? P. These two have to be parallel. You guys get that? Now, go over here to this one. Now, I have to be able to, there's 4 lines here, so there's going to be 2 other possibles. Let's see if L and M are what? Parallel. Well, if this is 48, is there any other angle that it's 48 degrees? Which one? And why? This one's 48. These are 2 lines that intersect. What type of angles are they? So if this is 48, what's this one? 48. What about those two? Are those 2 consecutive interior angles? What do they do? Add to 180. So what does that say about these 2 lines? They're parallel. So we can also say that L is parallel to what? M. Do you see why, though? That's the key here. If you can have either the ones right on top of each other, if they add to 180, the 2 lines are parallel. And then all the others are if the alternate interior angles are what? Congruent, alternate exterior angles are congruent, or the corresponding angles are congruent, you can say the 2 lines are parallel. Excuse me. Well, what do you want to make your transversal in first here on number 8? Pick one. AB. We picked AB. That means this is our transversal. So I'm going to ignore this side. Okay, I've got a transversal, and if it helps you, you can extend these lines. How do these two relate to each other? They're consecutive interior. Well, what do I know about consecutive interiors? If they add to 180, then the two lines have to be parallel. Do these two add to 180?
Yeah.
Yes, they do. So that means that this has to be parallel to this. So I could say that what? Segment BC, and you need to write this correctly, is parallel to what segment? AD, and I have to put segment above. You guys see how we did that? But there's four of them drawn here. So I probably need to what? Turn it over. What do you want to be your transversal now? BC or AD? BC. Extend that out. What about here? They add to 180, so what does that mean? So I need to write over here that those two are parallel too. So BA, segment BA is parallel to what? Huh? CD. This one's parallel to this one, right? I would name that with CD. Any questions there? Let's look at number 9. First of all, if this is 76, what's this? Okay, this line intersects this one, so obviously they're not going to be parallel. This one intersects. What's the only two that probably have a chance to be parallel here? These two are our two ones we're going to consider for being parallel. So this would need to be congruent to that. Let's see if it is. What's 76? Well, or this would be congruent to that. Is this an alternate interior angles right here? So I have alternate interior angles congruent. What does that mean? Those two are parallel. So what would I say? I wrote over it. What is it? VZ is parallel to what? Segment XY? And is there any other possibilities here? No, there really isn't, because they all intersect, right? Look at number 10. These are our ones we need to consider for being parallel, correct? Only do two at a time, though. Do you see any angles that relate to the other? 48 and 48. These two are congruent. What are those? How do they relate to each other? Erase the middle one in your mind. What are they? Corresponding angles. So I could say right now, because I have a set of corresponding angles congruent, that UW is parallel to what? SY. Now what about this one? If this is 48, what's this got to be? Huh? Yeah, that doesn't really help me though. If this is 70, this would have to be 70. Look here. Is there any way these two are parallel? Why? I'm talking about these two right here. Is there a chance those two are parallel? No. Why? Because these are corresponding angles, are they not? And are they congruent? No, they're not. So these are not parallel. So there's no chance that this one's parallel to this one, because guess what? If it's parallel to this line, it can't be parallel to this line. It can't be parallel to a line that it's also parallel to. Okay? So these are your only two. Now, 1 through 6 are the other type of problem on here, which are more like problems from the previous section. They're going to say find x so that that L has to be parallel to M. Well, if these two are parallel, then what do I know about 4x and 80? do they add to 180 or they have to be the same? They're corresponding angles, are they not? So they're congruent. So what would be my, it looks like an algebra problem. What do I need to create? An equation. What would I say here? What's my next step? X is equal to what? So we found X. It's not too terrible, is it? Let's scoot down here to 3 so I can have the other one still up there. Okay, for L to be parallel to M, how would this angle have to relate to this angle? First of all, how do they relate? This is they're alternate exterior what? When lines are congruent, what do we know about alternate exterior angles? They are? So what's my equation? 124 is equal to what? 3x plus 40, or what you were going to say. What's my first step? Subtract 40 from both sides. And I would get what? 84 is equal to 3x. Divide both sides by 3. What's x equal to? $28 maybe? You guys see how we're getting these equations?
What kind of angle would be number 1?
Oh, they didn't ask for the angle, they just asked for x.
Oh.
So once you found x, you're done. On number 2, they're saying this is parallel to this. What would x have to be if that's the case? How would this angle have to relate to this angle? They are what kind? If it helps you turn it like that, right? They're alternate interior angles, are they not? So they have to be what? Congruent. So your equation is what? 3x plus 5 is equal to what? What'd you guys get for x? Is that what you guys got? Let's look at number 4. They're saying that this, for this to be parallel to this, L to be parallel to M. Now, how do these have to relate to each other? What do you think a common mistake is going to be made here? Everybody look up here. Stop writing. Every single problem I've done so far, the first 3 problems, what did we do? We had 2 things and we just said that was equal to that, didn't we?
Yeah.
Does that mean you need to do that every time necessarily? No, you need to remember there's one situation when you have parallel lines and transversal to where they add to what?
180.
Is this that situation? They're right on top of each other. And if you look at it, when they angle it nice like this, does it really look like there's any way that angle equals that angle? And look how, that one's obtuse, that one's acute. So what do we know? That this plus this one have to add to what? So 65 plus 8x minus 5, all of that has to equal what? 180 degrees. You guys see how I got that? Because they're what? Consecutive interior angles. Now, if an equation looks weird, there's probably some simplifying to do. 65 minus 5 is what? 60 plus 8x is equal to 180. What do I do now? Divide both sides by 8. X is equal to 15. Any questions on that one? I'll zoom out and have them all up there in case you missed a piece when you're writing it down. A piece of the, you know, like you missed a part of the equation. Here. How's this one different?
It's right.
Well, they didn't give you, these have no relationship to each other. They're not corresponding. They're not consecutive interior. They just gave you, but you have to remember, they gave you, what do they mean when they put this box here?
It's a right angle.
So that's 90 degrees. What other angles do you know are 90 degrees now? What about this one?
That one,
And this one also has to be what? So what do you think 2x minus 4 has to equal? Because they were perpendicular, right? So add 4, 2x is equal to what? Divide by 2. X is equal to what? 47?